Cool. So let's use one more little function from processing to make the quality of our graphics a little bit better. Right? One thing that I don't like personally, based on what's happening here with the behavior we see, is that if I move my mouse really slow, I'm getting some really, really small circles, right? And visually, I think that maybe that's not so successful. So what we can do is we can add in some extra detail to our behavior, right? Our behavior right now is that the speed is being calculated from the movement of our mouse, and that speed is being used to define the size of our ellipse. All right, so if we wanted to be more specific, all we'd have to do here is add in some additional detail. So we will redefine speed with a minimum value. Okay, so in order to do so, we're going to say that speed equals, and we'll take the maximum, max, max, between the current value for speed and something that we specify numerically. Let's say something like 15. Right, so that would mean that the smallest circle can only be 15 pixels in width and height as a minimum, right? So everything can be bigger than 15, but not smaller, right? So that's, I think, a little bit better in terms of the graphics that we're producing. All right. So if you have any questions about what we've done thus far, let's go ahead and address them now. Drop them into the questions window. And while you're doing that, I'm going to do a couple of things to change with very simple manipulations to the program we've got already. If we were to and see what happens. Right? So if we remove the alpha channel, right, of our fill, we'll see that our circles aren't showing any overlap. Right? They're fully opaque. Right? So I like it better the way we had it. In terms of our transparency, I can make it more transparent if I say 100 here. Right? So they're even more transparent, showing through more. I think 200 was a successful value there. Again, we can change the minimum of our size of our circle if we were to manipulate this value here. And lastly, if we wanted to, if you noticed, our circles by default have a black edge to them, right? That's the stroke. So we could say that we want no stroke, and that will define all the circles as just fill. Now that's a little bit tricky with this level of transparency. We don't really see much detail. So I think it's maybe better that we keep a stroke. So maybe what I'll do is say that the stroke has to be white or something. We'll try a different color. All right, so just a slightly different effect in terms of what we see from our circles. I think I like the white better than the black. So I'm going to keep it like that. Okay, so a direct question for this file as we have it already, aside from the question about how we capture a display window. The question was, why is the first circle so big, right? Well, that's because the previous mouse position and from before we've even put our mouse on the screen yet is 0, 0, 0. So if I start my program, notice how it's already drawing circles on the upper left-hand corner before I've even moved my mouse onto the display window. So the defaults here are 0, 0, 0. And and the mouse position, as soon as I put it onto the display window, will be wherever that is. So if I start here, it's going to be small. But if I were to start on one of the other edges, like over here, right, the mouse position 0, as a different from the current mouse position here, is drawing a really large circle. Okay, so if we didn't like that, we could modify the values here again by saying that the speed would be a minimum between the speed and some value like 100, right? So that would prevent a really large circle, right? So the largest it can be is 100, but it won't be large enough to fill up the entire screen, right? Maybe try 200 here. Okay, so that would prevent a really large circle from being drawn in the canvas. And again, that has to do with these initial values starting at 0, 0. Okay. Another question before was about width over height. All right, and the width property again just references the size, and it's dynamic. So anytime after we've declared the size, we can use width to define any other property. All right. Okay, so let's take a second and go ahead and experiment with this file, make some modifications to the values, and run the program a couple times. And then in a minute or so, we'll look at how we might capture the display window. All right, so let's take a look at this last question, which is from the previous exercise. How do we capture the display window whenever we're ready to, or we like what we've produced, right? So if we were to run our program, and if we were, interacting with our little applet in the display window, we're creating some circles, and let's say, all right, I really like it now. I'm ready to capture it, right? So, one way to do this is if we needed to have the context of the sketch window also, we could take a screen grab, right, doing a print screen. But internal to processing, we can also capture just what we see inside the display window. All right, so let's go back to our reference and see if we can't find something that relates to that functionality. If we were to look down, there should be an option to save an image. So I'm going to do a find and see where we have image. Here we have it. It's under the image section under output, there's save frame, right? So this allows us to save a frame whenever we're ready by using the save frame, and then we'll specify a file name, and that file name will be stored wherever our sketch is located. All right. So let's first, I'm going to make sure that I save this. So I haven't saved it yet. Save to where I've been working on my files for today. This is simple behavior. W. All right. So anytime I save a frame, it's going to go into this folder, right? Okay. So let's see how we can actually execute this. Now, if we just use the save frame method, it will save every frame that happens, right? So the longer we run it, the more images we'll be storing, right? So you can see here in the description it says that you can pair this with the mouse pressed or key pressed methods in order to only trigger that action on a key event. So this is a little bit advanced, and we haven't talked about this quite yet because we'll be talking about conditionals in a minute. But let's look for the mouse pressed method in the previous window and see. Let's do a search for it. Mouse pressed. There it is. Okay. So if the the mouse pressed function is called once after every time a mouse button is pressed. All right. So if you want to find out which mouse button has been pressed, you can use this variable. All right. So there's also a similar method here. If we click that, so this says if anything on the mouse has been pressed, it's returning a Boolean, a true or a false. So we can use this little structure here. So I'm going to copy and paste this. If mouse pressed equals true, we're going to do something. All right, and I want just this much here. So Control C, copy that, bring that back over to my application. And inside the draw loop, at the very end, here, this is where I'm going to capture my display window. So if mouse pressed equals true, this is the pseudocode that goes with this, I'm going to say save frame, and now I just need to look at the format for what I need to produce here. So if I go back to save frame, it's giving me an indication I can use the pound sign as a way to reference the current frame number. All right, so we'll use this format here. So this is open quotes. I'll type in frame dash pound, 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 pound. That gives me 5 numerical positions, so I could have up to 10,000 frames. Close, dot PNG, close parentheses, and now anytime I press a button on my mouse, it should save a file. So let's go ahead and run this, see if it works. So I'm just moving my mouse across the screen. Click, 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 click. Notice that as I click, it's saving frames out every time to the folder where my sketch resides. Right? So here are all my frames. They're numbered incrementally based on where I was in the sequence. So you can see the preview change as I move through. Right? So that would be a way to conditionally save a frame. And that's a great place to start because you probably don't want to save every frame unless you've got your application running such that it's running smoothly and behaving the way you want it to. So that's a really great question. All right, if there are any others, let's go ahead and address them now and before we move on to the next exercise. So I'll save that. All right. Seems like we're ready to proceed. So let's move on to our next exercise.